Okay, continuing with factoring. We're looking at something called perfect square binomials, or the difference of squares. And it's another pattern, and I know you're thinking, I don't want more patterns, but it's a helpful pattern that makes them faster and easier to do. So it is a benefit. So let's take a look. Now this is the math language. Let's forget that. It never makes any sense. Let me just show you what this means, because it means something quite easy. We're always going to check for GCFs. Okay, we've already talked about that, but let's just dive in. There's no GCFs. I have square roots on the front and the back. I have them again. Okay, so just like we did in our last video, I'm going to write those square roots down. All right, now there is no middle term this time. And so when there's no middle term, you give it opposite signs. So again, I had a warm-up activity to try to show you this if I gave that to you. But so what we've got here, the reason there is no middle term is because when you FOIL this, you create a negative 2x and you create a positive 2x. The opposite signs make the middle drop out when you FOIL it. So someone just noticed this, that if there's no middle and you have this negative in between, you give it opposite signs. Okay, so we just saw one, so you can pause it if you've already got the idea, but I'll show you. I see square roots on the front and the back. All right, and I got that minus, no middle there. It gets opposite signs, and that's all there is. Same thing here. I'm going to write, I see square roots on the front and the back. Now maybe you don't see the square roots, use your calculator. Got no middle, so this time it's opposite signs. In the last video we had the square roots and we had a middle and it was two of the same sign, but here it gets opposite signs. Okay, now it's a little more complicated, but we have, can I just trust them? Yeah, they did fine. So I've got square roots on the front and the back, so I wrote them down. One has a square root, it's 1. No middle, opposite signs. Yeah, they're just showing you here that 1 has a square root. So m and m are my square roots in the front. 1 and 1, opposite signs. As always, pause it if you want to try, but same thing. I do have square roots in the front and the back. Opposite signs since there is no middle. Okay, it doesn't change with y's on the back. We've seen that many times now. We still are just going to put I do have square roots on the front and the back. They're just more complicated, but they're still square roots. There's no middle, opposite signs. You know, I've fallen for that trick before. It's actually 14m is my square root. And my square root on the back is 5n. No middle, opposite signs. Keep going, same thing. You can always stop it and work it yourself. I'm going to write my square roots down. No middle, opposite signs. Okay, so the twist on this one is now we've gone backwards. It won't change anything. I'm still going to do my square roots on the front and the back. The h's are in the back. Doesn't matter. Won't change anything. So plus and minus because I had no middle. It's out of order, but it doesn't matter. I got square roots on the front and the back. No middle. Opposite signs. Another the same. Again, use your calculator if you're not sure that there's a square root, but there is on this. No middle. Okay, now something interesting is going to happen here. So let's go through this. I don't want to do it their way. So do you see that this does have square roots on the front and the back? X squared times x squared, which is the definition of a square root, two of the same thing, makes x to the fourth. And on the back, y to the second, y to the second. Now there's no middle, so we do opposite signs. But here's why they are working this problem. There's two of these. Now this is not done. It could be factored again. So suppose you had 2 times 4. Well, 4 is not finished. It can go further, and you have to take it all the way down to the end. Now I'm going to come back to this one on the right in a second, but I've got square roots on the front and the back, so I'm going to do it again. Okay, I have no middle, so plus or minus. And now I'll explain this in a second, but I'm going to bring this guy down. And that's finished. Now, here's what people don't see. X squared plus 9 is actually impossible to factor. That is prime. This only works, I have the square roots on the front and the back, but there's no way to make this. So suppose you said, okay, well, it should be x minus 3, x plus 3. Well, no, we've already seen that makes x squared minus 9, so that is not it. Well, what if you tried x plus 3 times x plus 3? Well, we saw in the last video that if it's two of the same thing, you get a middle term. So that isn't it. And if you did it with x minus 3, that's still not it. We saw two of the same signs make a middle term. This is actually prime. So it's not good enough to just have square roots on the front and the back. It has to have a negative sign in between them. So back to the original problem here. I had square roots on the front and the back. No middle, opposite signs. This one is finished, but this one can go further. Just like 2 was finished, but 4 was not. So I keep going, and I'm done. Okay, try this. It's going to be that same issue. Just be careful about what's prime and what's not. Okay, square roots on the front and the back, there's no middle, so opposite signs. Now the one here on the right is finished, but I'm going to take this one further. It still has square roots on the front and the back. Okay, and I'm done. This is the most classic version of this one, because look what happens. I just jumped to the end because I knew what was happening. This is prime on the right. The left is not finished. It can be done again. Okay, let's take out a GCF, and then we're going to have the same pattern. So my GCF here, I can pull out a 2y. I then have square roots on the front and the back. Just one extra step. Here, I'm assuming, that's a weird one, but I'm assuming 7x is my GCF. Yeah. Okay, so I've pulled out my GCF, can't forget about him, but this is going to break down just like it always would. Square roots on the front and on the back. Okay, pause it if you want to try. I think you can take a 5b out of there. Let's see if I'm right. Okay. Now, the reason they did that is I have square roots in the front and the back. I got the minus in the middle. And we are going to get this. Yeah, I think I see. So here what's going to happen, I pull out my GCF, always do that first, but you now have x squared plus 16. I've got a square root on the front, I've got a square root on the back, but I don't have the negative. So this is finished. I can't go any further. Same thing's going to happen here, I'm sure. We can pull out a 2, which leaves 4a squared plus 100. These have square roots on the front and the back, but there's no minus, so I'm done. Yeah, just more of the same. Yeah, This one, there's nothing you can pull out. This is the difference. I have my square roots on the front, I have my square root on the back, but the plus in the middle makes this finished. So there's no GCF, there's nothing. This is prime. Oh, hold on. No, well, you could do this. There is a GCF here. You can take out a 9. That's what they were doing. You can take out a 9, and you'd get this. Now this still has square roots on the front and the back, but it can't go any further. And this would be the best you can do, because the minus there prevents it from going further. Okay, that's the difference of squares or perfect square binomials. And that's got a pattern too. I know all these patterns, but these square root patterns make it much easier. Now the hardest one, we got one left, and it's coming in the next video. You're not going to like it, but you can do it, so stay tuned.